Hello. Today I'm going to be talking about some of the processes in the nitrogen cycle. And before we get into all that complicated metabolic stuff, we must first answer the question, why did this take Wait, no. What is nitrogen? Whew. Well, nitrogen is the seventh most abundant element in the universe and is even present in our DNA. You see, nitrogen is a chemical element with symbol N and an atomic number of 7. Now that all that is out of the way, let me show you my nitrogen cycle. No, I mean the actual nitrogen cycle. There we go. Now I did steal this, so we're going to ignore both the Haber process and lighting. Alright? First things first, we start off with the nitrogen that's in the atmosphere, dinitrogen. Alright? This type of nitrogen is completely unusable by us. We breathe it in, we breathe it back out, nothing happens really. So to make use of this, before it becomes that negatively charged stuff that our cells know and love, it has to become ammonia first, right? And this happens in a process called nitrogen fixation, all right? And that is when nitrogen seeps into the atmosphere and is picked up by the nitrogen fixing bacteria, right? These guys that are named right here. And they're the ones that are really responsible for a lot of this cycle. As you can see, a lot of bacteria is responsible for the things that happen in this cycle. So here I have noted the equation for nitrogen fixation. All right? We see that the bacteria take up 1 nitrogen, dinitrogen, 8 positively charged hydrogen, and 8 obviously negatively charged electrons. These are then converted to 2 ammonia and a dihydrogen. Whew, not dinitrogen, that'd be weird. It would be balanced. Now, this ammonia is going to be used to convert the nitrate. Is going to be converted to nitrite, from nitrifying bacteria through a process called nitrification. And would you look at that? Somebody seems to have just left us with this equation right here. How nice of them, right? Well, we might as well make use of it. Firstly, we have an ammonia right here, and an oxygen right here, and 2 electrons who are just chilling in the dirt, I guess. These are then converted into NH2OH and an H2O, which is a water molecule. All right? Then these guys up here are going to come down here for a second reaction. The same NH2OH and a water molecule are going to be converted into nitrite, 5 hydrogen and 4 electrons. All right? We're, I guess, going to go and chill in the dirt again. And while our nitrite is chilling in the dirt, it meets up with some boys, some guys who we like to call more nitrifying bacteria. And then they start a process again. So the process this time, however, takes up 1 NO2, 1 nitrite, and a half oxygen, right? Half an oxygen, not hard, and it gets transformed into that real fun stuff, No, not LSD. Nitrite. All right? With nitrate, the process really gets started. This is when we start to come in, or well, plants, and then us, I guess. First, the nitrate is taken up into the roots, right, of plants, and then these plants here, I'll show you a beautiful artist rendering that we have of a lovely plant, and you'll see that some of the nitrogen is used in the plant to make chlorophyll, and that is that is why the plant is so green here, as you can see. And I'm going to show you another beautiful artist rendering here in a minute. And this one is a little different, you see. So just like in our lovely work of art before, we have here a rabbit. So suppose that a very hungry rabbit has happened across our plant here. We'll call the rabbit Count Fluffula, because that name is awesome. Now suppose that Count Fluffula has eaten our plant. Yeah? Now most of the nitrogen will get up into the rabbit, all right? Along with some other stuff. But this is not the CO2 cycle, is it? Clearly, right? See, it's not. Moving on. Both plants and animals die eventually. So Count Fluffula, I'm sorry, buddy, but you're gone. So everybody say goodbye to Count Fluffula. All things die, really. So the plant dies, we die, and stuff like that. You know? No, it's not my time yet, all right? It's not my time yet. And with death comes decay, and in this case, decomposes, referred to in this diagram as saprobionts, right here. So when the plant dies, saprobionts, or decomposers I'll call them, take up the plant proteins, anything else, or well, the nitrogen really that was in the plant proteins, and they change it into ammonia by the same nitrogen fixing process. And the same goes for the animal protein. So Fluffula is now ammonia, all right? I know it's sad, but I guess you never truly die. You live on as gas. Not a ghost, though. So really what these decomposers do is they take your standard corpse, or zombie in this case. No, I didn't draw it. Leave me alone. And they transform it into, drumroll please. No? Okay then. No big deal. Into ammonia. Wait, what do you mean I didn't draw this? Hey, I caught you, idiot. Look at this mistake. Idiot. Oh. Right. Well, finally, we have the other branch of the cycle, denitrification, right? That happens over here, which, as you see, is done by denitrifying bacteria, all right? And once again, it just so happens that I have the processes right here. This, my friends, is denitrification. Here we get a nitrite, and then the nitrite is converted into nitrite. Okay, wait. I know what I sounded like I said. All right, first of all, denitrification actually occurs in two different ways, both involving denitrifying bacteria. But the first way, we start off with a single nitrate molecule, and that is transformed into a single nitrite molecule by the denitrifying bacteria, and then that becomes NO plus N2O, and then that becomes dinitrogen, and that goes back up into the atmosphere from the soil. All right. The second way is by having 2 nitrate, 10 electrons, and 12 hydrogen. These are then transformed into a dinitrogen, and 6 water molecules. All right. But wait, there's actually more to this than just it going around in a circle. You see, we're actually adding to this cycle. So we affect the cycle too. Yay, I guess. Or well, not so yay actually. Because, well, I'll get into that. But the two main ways that we add to this cycle are by using nitrogen-rich fertilizers. See, so all these lovely crops that are being reared in this lovely, lovely farm here are very likely being raised on very rich in nitrogen fertilizer, or nitrogen-rich fertilizer. And the second is, unfortunately, by burning fossil fuels, which, for a number of reasons, is bad. So if I can leave you with at least one thing, it's that nitrogen is very important, but we should not overdo it. As burning fossil fuels and using these fertilizers can actually create a substance called nitrous oxide, which can actually harm the ozone layer. So be careful, guys. Also, thanks to NASA for the photo. Couldn't have done it without you, boys. And finally, we have, thanks NASA. Finally, we have my citation from, this is where I did all my research. and I actually got the cycle from this website. So nature education knowledge, this is a very useful website. Finally, thank you guys for watching this video and bearing with me through it all. I know I made a lot of mistakes, but I feel like I did get the point across. Thank you very much. You're awesome.